Welcome to my presentation. In this presentation, we shall solve some examples using the power rule. So let's get started with some examples. Example 1. Let's say we have a function of this kind. If f of x, if a function is equal to x to the power of 4, then the way we want to find the derivative for that is as follows. Step number 1, we'll solve it using these different steps. First step, we want to know what the power rule is. The power rule is stating that if we have x to the power of n, the power rule is stating with the derivative, we can write it out as nx to the power of n minus 1. So in here, the first derivative is going to be equal to n here is 4, so therefore 4x to the power of 4 minus 1. So we can simplify this as 4x to the power of 3. So that is our answer. So the derivative of x to the power of 4 is going to be equal to 4x to the power of 3. So let's look at another example. If y is equal to 1 over x to the power of 2, we can simplify this, or we can rewrite this equation as y is equal to 1 times x to the power of negative 2. All I did was bring x to the power of 2 to the numerator, which was in the denominator for the given function. When we bring it up, the exponent in the denominator, if it is positive, it changes to negative. So in here, it becomes x to the power of negative 2. So 1 times x to the power of negative 2 is same as x to the power of negative 2. And now we are ready to apply the power rule to this. So therefore, the first derivative, dy by dx, is going to be equal to n, in this case, which is equal to negative 2, times x to the power of n minus 1, negative 2 minus 1. So therefore, we can write this, simplify this one as negative 2x to the power of negative 3. Negative 2 plus negative 1 is negative 3. So therefore, this is our answer. If the given function is y is equal to 1 over x squared, we can write that as, we can write the denominator, bring it up to the numerator, and then write it out as a negative exponent, and then apply the power rule to it, and therefore simplify it. In fact, we can simplify this answer a little bit more as follows: negative 2 times 1 over x to the power of positive 3. Now we have x to the power of negative 3 in the numerator. When we bring that to the denominator, the negative exponent becomes a positive exponent, like that. Therefore, we can also express our answer as negative 2 divided by x cubed. That is another way of representing the answer. So that is how we want to use the power rule to be able to simplify these types of problems. Let's look at another example. If we have a function like this, g of t is equal to t. G of t is equal to t. We want to find the derivative of this function. So the way we do that is as follows. G prime t. We are differentiating the given function with respect to t now. Therefore, according to the power rule, we can write t as t to the power of 1, isn't it? So therefore, the first derivative of this given function will be equal to nx to the power of n minus 1. In this case, n is equal to 1. Therefore, we can write this one as 1 times t to the power of n minus 1, 1 minus 1. And since n is equal to 1, we write that as 1 minus 1. Therefore, 1 times t to the power of 0. Whenever any term is raised to the power of 0, that value is going to be equal to 1. So therefore 1 times 1, and therefore that is equal to 1. So our answer is going to be equal to 1. So when we have a function when we have a function g of t which is equal to t, the first derivative of that function is going to be equal to 1, like that. Let's take another example here. So in this example, if r is equal to x to the power of 4, we want to find the derivative of this function. So dr, we are differentiating this function with respect to x. When we apply the power rule, we're going to write it out as nx to the power of n minus 1. In here, n is equal to 4, so therefore we're going to write this one as 4, n equals to 4, so 4 times x raised to the power of 4 minus 1, n minus 1, 4 minus 1. Therefore, 4 times x to the power of 3. So that is our answer. That is where we want to leave it. So no matter what kind of function we have, as long as it is, if it has a power, if it has an exponential part in the function, we can use the power rule to be able to simplify it. In my next presentation, we shall see more examples using the power rule.